We're trying to circle something. Like what happens as x is getting bigger? What's happening to the y values? So we say that usually, like in algebra 1, you say that's a positive correlation, right? Well, you notice on this one also, as x is getting bigger, y is getting bigger, what would you say the difference are between those first two graphs? Yeah, this is more spread out, this is really close together, and so they draw the circle to try to help you see that you could call this a strong positive. So it's not just positive, it's strong positive. Because they're really clustered close together. Whereas this is still a positive linear correlation, but it's not super close together, so we say that's a positive linear correlation. And people always get really hung up on this. I'm like, well, I think it's strong, I think it's weak. At least you get the positive part. Hopefully you can realize if it's super close together, it's strong. We say it's a linear correlation because remember, like, you go draw on that line and that's it. To predict that. What would you say this is? Yeah, this looks to me like there's no correlation because at 10, there's a really high value, but then also there's a really low value down here, and it's high and low. So this is like no relationship. So it says little or no relationship. Like if I asked you all your shoe size and how many pets you had, probably not a correlation. But if I asked you how tall you are and your shoe size, probably there's a correlation on how tall you are. And then I always struggle coming up with examples of this, but this would be the bigger that x gets, the smaller that y gets. So we normally say that has a negative correlation, but again, we're just going to be more specific and say that's a strong negative and that's a weak negative. Yeah, I always say, like, the more kids you have, the less money you have. But that's not really true. The more kids you have, the less patience you have. The less care you have. People that don't have a window, they're always like, I wish I had a window. And I'm like, you don't know what it's like to have a window when your smartboard faces the window, because people are like, oh my gosh! There's snow! Like, snow is very sexy. But then also sometimes they're like, look at that bird! That bird is so big! Or in 6th hour, we had a bird running to the window. That was a little stressing. It's left some feathers up there. And then, one year there was a dog or a cat, I forget which one, I think it was a cat. There was a cat that would always show up, and students tried to get me to go out and touch the cat. Windows are distracting. So it says a group of male children were weighed. Their ages and weights are recorded. Notice their ages in months. So most of the time after age 2, people don't usually say their kid is in months, but they're going months like all the same. So normally you don't say your kid is 39 months.
Why do they say months?
Because the difference between a 1-year-old and a 2-year-old, like, lots of things change dramatically between 12 months and 20 months. So, like, when you say I have an 18-month-old, people with children know that's very different than saying you have a 13-month-old. 13-month-old, like, don't let stop at all. That's when you want. 80-month-old, they should be, like, 12. So that's why you say it. Because there's lots of milestones that happen over that time.
I'll just say they're 1 year old.
Right, because they, and especially when your kid's little, like, you get very excited for every month that you expect them to last again. You're like, card for it. Okay, so which one of these should go on the x-axis, or doesn't matter? Usually we try to put the independent variable on the x-axis and the dependent variable on the y-axis, and usually, right, time is always your independent variable, so I think we should put age down here. It depends. Usually, I would say probably the average is like 20 pounds, but my sister's boys didn't weigh 20 pounds at age 12 months, and my 8-year-old weighed 20 pounds at like 7 months. So it's very, it fluctuates from kid to kid. Which is why when you have kids, you go to the doctor, they give you this like percentage of like where your kid is on the chart compared to all other kids their age. So there's like the 50th percentile, like your kid's right in the middle of all the other kids that age. So my kids have always been, Parker has always been above the 99th percentile on height. Like he's taller than 99% of, like he's off the chart in height, which means he's pretty high on the weight chart too because he's so tall. 50 percent. I don't know what he's like something. Maybe. Maybe he's really tall. He's only like, there are 6th graders in this building that my son is taller than, and I see them in the hallway, and I'm always like, are they lost? Like, what is that little child doing here? Because there's some teeny tiny 6th graders in this building. They seem like they're this tall, but Mrs. Bai's son, Brian, is 7, and my 3-year-old is like this much shorter than me. Like kids are just very, like Brian's pretty short for his age, and my kids are really tall for their age, and so I took a picture last year to show my husband. I was like, look at Brian and look at Nolan, like they're almost the same height, and Brian. My kids, I always said they needed a shirt that said, like, I'm only 3, because people think they're a lot older, and then they wonder why they're acting like a 3-year-old. Or, like, right, like, people think Parker's, like, 10 or 11 or 12, and he's, like, 7 or 8. And I'm like, he's only 8. He's only 8. I'm like, he's only 8? Please, don't judge my baby. What happens if you have tall children? As opposed to if you have short children, people think, wow, look how advanced that kid is, right? Because they're like, look what that little child's doing. They're like, oh, they're 14.
I got
Should we make our x-axis go by ones here? I think that would be a terrible idea, right? 5. Oh, I hate the squiggly line. So I'm going to start at 15. That's still a lot. I'm deciding. You can do what you want to do with your picture. I'm going to go by 15 and go by 3s. What do you think about that? And then we're going to put the weight up here. Do we want to break the y-axis as we're breaking the x-axis? I'm really bad at it. Threes? Okay. Wow. 20. Oh, but I can't. I'm going to start at 21 then. I can't count by 3 starting at 23. I just can't do it. I have to start with the multiple of 3. 23? That's awful. let's just plot these. 18 months, 23 pounds, 20 months, 25 pounds. Tell me if I just did it really wrong. 24, 24. I always love when my kids are as tall as they weigh, like when it's the same number. It makes me nervous. I think that's a math person. No, like in.
So like,
In inches.
if they were
You do.
180 inches.
that's more than like 2
Nolan,
tall.
Nolan was about the same, not long ago. Nolan was like 30-some pounds and 30 inches.
It's really tall.
Okay, well, it doesn't work when you weigh 180 pounds, but when you're little, it works. like Parker is like around 5 foot, so he's like 60 inches, but he weighs like 70 something. So he's already like super weird. Nolan, he was around 36 inches. That was like only math people. Only math people think. What if he lets you down and doesn't try?
I will go to Chicago and get smacked. I already know it.
Oh look, 29, 29.
I did.
34, 35. 39, 39. 42, 44. So, would you say this is a positive, weak positive? Strong, negative, weak, negative. Definitely a positive.
Getting direct calculators.
So, remember back in the day, you could draw in that line of best fit, and you could write the equation for that line of best fit to predict other weights of other children and their ages. Like, we could draw in that line, and then we could be like, I wonder how much someone who's 70 months old would, how much they would weigh based on this chart, right? And it's kind of a pain to do that, but your calculators will do this for you. And you can make a scatter plot on your calculator too. Okay? So, one second. Oh, here we go. Let me without stopping one guy. How many seconds? So, do you think you've been alive for a million seconds?
Yeah, it's not interesting.
Do you think you've been alive for a billion? Well, sorry, I gotta check it. I'm just saying. Do you figure out sometime how many seconds over there?
493 million.
No, don't cheat. Use one second.
I'm doing
I'm not using one second.
So, step one. Go to y equals and clear out anything else.
Are you about to blow our minds?
No. Okay, I'm just wrap up the second. You are a million seconds old when you're like 6 days old. Like really, really short time. This is kind of to get you an idea. Think about like talk about $1 billion, $1 billion. So you are a million seconds old when you're 6 days old. You are not a billion seconds old until you're and a trillion you would be dead. It's a lot. I gotta remember, but like it's like way over. And so thinking about that when they talk about $1 billion or like billionaire, they talk about $3 billion or whatever. Crazy, right? And I'm with you. It blew my mind when I found that out. No, you don't need to. You should just do days, hours, minutes, seconds. And really, if you really want to think about it, you have to think about it. So, you don't have to do it right now. But I'm just saying, none of you have been alive for a million seconds. Because you were alive for a million seconds. Isn't that crazy? Yes, I want to say it's like 31-ish. 31. Not 32. Okay, back to that. I think that was that. So, clear this out, and then you're going to hit this stat button right here. And then we want to edit the stat. So it should be on edit, and you're just going to hit enter, and you see these columns like this that should say like L1, L2, maybe you have some numbers in there. Yours have numbers in there? So you want to clear these numbers out, and you could go through and clear everyone out at once, or you can just arrow up to where it says L2 and hit clear, and then if you arrow that down, it just deletes all ones. Arrow up, hit clear. So L1 is going to be our X values from our weight chart, and L2 is going to be our Y values. So just take a minute and enter in all those months, and then enter in all the weights. L1 is our X, right? You just hit enter afterwards. It should look like this, like a list. Or just go down. Got it? Because I hit it 5 times. This is supposed to be like, if I want to do the follow the buttons I hit, like I can be like, do this, right? But you don't, I can do it. So I can be like, follow these exact directions. Okay, so we want to change our window to what we made our graph to, because otherwise, like, it's not going to show what we want to see. So, you click the button right here, I'm going to hit window, and I'm going to make my graph look just like the graph we made, which means we started, well, I don't know what you started with, but I started at 15, and I went to 42, right?
Yeah.
So I'm going to say my minimum is 15, you can make it whatever you made yours, my maximum is 42, and then we counted by 3, so that's my scale, so I'm going to put a 3 there. And then my Y values, we broke that graph too. I started at 21, you started at 20, you started at 23, that's there. I'm going to start at 21, and I ended at 45, I think. And again, I went by 3. To me, using a graphic calculator, understanding how to change your window so you can make the X, Y feature that you want to see is like the most important feature of the graphic calculator. So the other thing that we need to do before we can see our scatter plot is we have to tell it to graph our scatter plot. Well, if you already, if this was, we did this now for 2 last week, so maybe yours is already on, because you did that. So let's try. Mine's not going to be on, so if I hit graph right now, it's not, oh, it is on. If it doesn't have, here's what you have to do. Above y equals, you see where it says stat plot? So you have to hit second y equals, and you just need to change that from off to on. And so if you just hit enter, off is highlighted, you just hit on, What's kind of cool is you can make Instagram, you can make some whisker floss on graph calculators. That's really nice. Anyway, you should see, hey, that looks like what we graphed on paper, right? So maybe you're not impressed yet, because you're like, I could have done this on paper fast. But here's the cool part. It will write the equation to fit that data. So I'm going to go back to stat. And now I'm not going to edit, now I want to calculate. So that's the second column over there, so I'm going to arrow over to calc. And you can do a whole bunch of statistics stuff on these calculators. Now look at number 4. Number 4 is a linear regression model, which means the line that fits your data, a linear line. Notice there's also a quadratic regression, a cubic regression, which means if you had data that was like a parabola, you could do it for that too. But you can either scroll down to number 4, or you can just hit number 4. And I think you have to hit enter. You don't have to hit it every time. I have to hit it. But I think if you just hit enter like twice at some point, it should give you y equals ax plus b, and it gives you the a and the b value. Which means it's giving you that slope-intercept form. I'm going to drop that off a little bit. 0.825x plus 7.818. That would be my prediction equation. So then I could plug in any value for x, or mean any age, and I could predict the y value that goes with that. But does not work. Well, it should have entered your graph. Oh, look, that's why. That's kind of cool, right? Yeah. So anyway, there you go. Way better than my 8 minutes. Okay, now we have to talk about quadratic stuff too. Like, we could predict, like, if we wanted to use that equation, I could say how much would be someone that's 50 months old weigh. You plug 50 into that equation. You get your... The other thing we want to talk about is vertical free fall motion, which we've talked about before. We talked about projectile motion. This looks a little bit scarier, right? It says the height s and vertical velocity v of an object in free fall are given by this scary equation: -1/2 gt squared plus v sub 0 t plus s sub 0. Your time is in seconds. G is your acceleration due to gravity, which, depending on whether you're in science class or in math class, in feet, that's 32 feet per second squared. In meters, that's 9.8 meters per second squared. So it depends on which you're in, if you're in feet or if you're in meters, on what number you plug in there. V sub 0 is your initial velocity, and S sub 0 is your initial height. When we did this before, we were doing it in feet, and I gave you this equation. It's -16 t squared plus V sub 0 t plus S sub 0. Remember that from chapter P? And that's just because the -16 is because we were doing feet. So if you plug 32 times -1/2, that's where you get the -16. But if you were in meters, you have to take half of 9.8, because you get -4.8. Okay? So same kind of question, only now maybe we can use form of our quadratic equation. Maybe? I don't know. I think I don't want to. This is what we'll get. So,
Yeah, but my question is,
at the Bakersfield 4th of July celebration, fireworks are shot by remote control into the air from a pit that's 10 feet below the person. Find an equation that models the height of an aerial bomb t seconds after it's shot upward. That's the fireworks, not a real bomb. T seconds after it's shot upward, for initial velocity of 80 feet per second. Graph the equation. What is the maximum height above ground level that the aerial bomb will reach? How many seconds will it take to reach that height? So, you might think, who cares about this? But when they're putting a fireworks show, they have to make sure that the fireworks don't land on people watching the fireworks. or houses or whatever. So they have to actually use some math to figure out where do I need to shoot these from so that people will actually be able to see them and it won't kill anyone.
I live dangerous.
So we're talking about feet here. So because it's feet, I know it's going to be negative 16 t squared because negative 1/2 times 32 feet per second plus v sub 0 t plus s sub 0. V sub 0 is your initial velocity. So how fast is our bomb flying? 80 feet per second. So I'm going to plug 80 into that. And S sub 0 is my initial height. How high am I? I'm 10 feet below the Earth's surface. So that's negative 10. Look, I wrote X here and T here. So I wrote X, but then I used T, right? Like you should use the same group. So part A is write that equation, and it has this little picture here because I want to use a graphing calculator, but I don't like to have a graphing calculator, so that's why I say you don't have to graph it. Part B says, what is the maximum height above ground level that the bomb will reach, and how many seconds will it take to reach that height? So here's my pit here, my 10 foot below the surface. I'm going to shoot this firework, and then it's going to come back down. At what is that point called that would be the maximum value? The vertex, which means you need to find the vertex of this. So you have two ways you can find the vertex. You could do the way the homework showed you, that way, or you can complete the square way that I showed you. I'm going to complete the square. But you can do the negative b over 2a, but you have to plug it back in to find the y value. Because we need to find the whole vertex of how high will it reach, that would be the y value. How long will it take to get there, that would be the x value. So I'm going to complete the square. Mostly because at some point it's y value. I can't just divide through by a number right now, right? Because this is not equal to 0, so this is where, like we did on the homework, I'm going to just factor out negative 16. Which means that's going to change to a minus, right? Because I'm dividing by negative 16. What's 18 divided by negative 16? I'm not going to factor 16 out of that negative 10, right? It's just kicked to the end. I'm not completing the square there, so I'm just going to kick it out there. Let's put the square. I'll take half of the middle number. Oh, it's a fraction. You can... I'm going to use a fraction rule, but you can say 2.5. Because in my head, like, if I take half of 5, it's 2.5, 2.5 squared. I don't know what that is off the top of my head. But fractions, I can say half of 5, and I can square it, and I know that that's just 25 over 4. So that's why I like fractions, and then maybe at the end I'll change it to decimal. But it's just easier for me to square fractions. Because I hate having to get fractions. Here's what happens when I give this on the test, alright? People put 25 force on the inside, and then they put 25 force on the outside, and they leave that their answer. What did they forget? Okay, they finished the problem, but this is what they put on the outside, and then they get that that it's a negative height, right? Like if you did this, that's a negative height. Which is something's gone wrong if our firework is negative feet in the air. Someone is getting hurt. Remember that you have to undo what you did out here, but don't forget about that negative 16 in the front, right? So like I really need to multiply this by negative 16. This is why the advantage is going to be negative. then I get t minus half of 5. I'll be a decimal lover like you. Half of 5 is 2.5. Then you can do this on your calculator, but this would become plus, because negative then a negative. 4 goes into 16 4 times, and 25 times 4 is 100. So negative 10 plus 100 gives me plus 90. So yes, I know this is a little bit of work to do, but I like it because if you do the negative b over 2a, that only gives you one part of the vertex, and you still got to plug it back in, so you still have to do some work, but I'm okay if that's what you want to do. But I like this because I can look at this, and I can say, well, my vertex is 2.590. Think about this is the x, this is the y, so that means that it goes 90 feet in the air, and it takes 2.5 seconds to get there. So I'm guessing they dug the 10-foot hole because they thought that was too high for them. Worst parachute. All right. So on your homework, you have some questions and just talk about is it strong, positive, positive, and then you have something that like pick the airplane. Choice. Some that say pick the right equation, which maybe you can use certain tools to figure that out. If you guys figure, I think this is only 3 questions if I remember correctly. I may be thinking just kidding, there's 77.
I wouldn't do it.
I thought I ever get 77 dollars.
I would hope not.
No. Well,
What the great
right. There's 4. I lied. There's 4.
Oh my gosh.
But look at the first one. That's the whole part. There's not even a part B. Describe the strength and direction. It doesn't even have you pick between strong and weak, right? Like, they're giving it to you, right? So, you have 10 minutes in here. I know it's Friday. You should be able to get some of it done, maybe all of it done. And then on Monday, we will go forward. You might keep your calculator for a minute just to